morning I put another class. Afternoon I don't take in Saturdays. Okay. So you have a Saturday and Sunday, guys. So please compulsory read. Also, I will try to forward certain videos. Please go through. Okay. That's how we'll go maximum today, tomorrow and day after tomorrow. Prepare your board. Of course, do not keep aside about your communication. Communication is important. Next is technicalism. Okay, so compulsory. So I
Tomorrow
already
will be class or not?
tomorrow no class. Tomorrow no class. I have another class. That morning session only having morning session tomorrow. For you, I cannot put in tomorrow.
Okay, sir.
We'll class on Monday. So today, this topic we'll see. One is topologies. Next is I'll give you a basic overview of OSI layers. Okay, today. So well, little bit late, but still will complete. Only IP address and main IP address part is left over. That we will take care on Monday. And tomorrow and day after tomorrow, try something about what are the course you find already completed, today's topics, first 2 to 3 days topics, and also I will give you certain materials also you can try, or you can try to get a certain things like what is the ping command, what is trace rt commands also. Okay, I will give you guide you through WhatsApp for 2 days. So just try to learn. So quickly complete this technical part quickly, and also prepare your communication for version test. That is important. Your version completed, then technical interview. But you won't give it time. Okay, time is not enough between version and technical interview. Okay, so that's a point. So be prepared earlier. Okay, so here it is. Two type of topologies: physical topology and logical topologies. Physical topology, the way of device connected physically, the way of devices connected physically, like a network. How you are connecting devices, how you create a network. That is a physical topology, the way of connecting physical topology, devices, physical topology. What is logical topology? Logical topologies means the way you configure IP address to communicate. Okay? The way you configure your IP address, IP network configuration, IP network
Sir, your voice
configuration.
is breaking, sir.
You tell me,
Your voice is breaking, sir.
my voice is breaking.
Yes, sir.
My signal is, I think my that speed is good, but when you find any disturbance, the voice clarity, 1 second, so that is voice or a video connectivity. So it is most problem, it is internet problem. I thought it will be somewhat better. My internet is somewhat better. 30 is more than enough. I will get normally 50. Now, guys, are you able to hear?
Yes, sir.
Yes, sir.
See? Good. Okay. So, what is a logical topology? It is based on your IP address configurations or a IP network. So, a network will be in a logical way, different networks. So, simply to tell, this is I have a very big switch, for example. I have a lot of computers are connected. So physically, all devices are same network. Physically, all devices are same network. We can divide this physical network into logical way by assigning IP address with a different network IDs. So when you learn about a IP addresses, network IDs, then we will understand the terminology. But logical addressing means so logically a network. So for example, this physically one network, you can make these species as a logically one network. Also possible. That based on IP address part. So very simple guys. First of all, we want a physical topologies. Physical topology is a basically the way physical connectivity of devices. Just connection. Okay, just a connection. The first one is bus topology, ring topology, mesh topology, star topology, point to point, multi-point, and hybrid point. Of course, I have a diagram, but for you, I am going to design from start. For explanation, I don't give more theory points. That's to our understanding. By looking at any topology, we can say what kind of topology. In a guideline, so there is a lot of topologies are there. Even some people are asking what is street topology, what is bus topology, what is car topology, what is cycle topology kind of stuff. Okay, I don't know those many things. See, guys, this is a bus topology. So there is a backbone wire, just like a your cable TV network type, like a coaxial cable. A backbone wire is there, and devices are connected to this backbone wire. Devices are connected to backbone wire. So devices will communicate each other, A to B, B to C kind of stuff. They'll communicate each other through backbone wire. So this type of topology we call it as a bus topology. Bus topology. We want to communicate from A to B or A to C. Can communicate via bus topology. It is very easy to configure, easy to maintain. But there is a problem. What is the problem? If in case, if this backbone wire is broken, no further communication. We can communicate up to here, but no further communication. Okay? So it confuses where exactly the problem is occur. Again, you have to trace back, right? So, so one problem is there in a bus topology. Very importantly, if backbone wire is down, total communication stops, or if backbone is wire is broken at certain point, the further communication also will stop. That is your bus topology. Okay, guys understand bus topology?
Yes, sir.
Here, yeah, we take a devices and we connect one device to another device, one device to another device, and one device to another device will connect, and finally last device is connected to the first device. For example, you put a name of these devices like A, B, C, D. Now A is connected to B, B is connected to C, C connected to D, D is connected to E is connected to A. It form a ring. That's why this topology called as even this topology it is ring topology. So you want to send a packet from A to C. So A to B and B to C, you reach it. You want a packet from A to D. D means A to B, B to C, C to D. Even A, E, D is easy, but it is in one direction only. So you have to configure this each and every device how they should communicate. clockwise, anti-clockwise, like that. So we'll configure initially clockwise communication. In clockwise communication or anti-clockwise communication, if any device is down, no further communication. If wire is broken, no further communication. No further communication. So you can look at here it is. If C is down, A want to communicate it to D. A send a packet to B. B to C, no communication, packet drop. If D want to communicate A, there is a path. But A want to communicate D, no path. Because C is down. Alright? This wire is down. So this is a problem. But it is very easy to configure, works based on algorithms. Some people what they know, so they want to make it as a much better way. So they'll create a double layer. This is a double layer means clockwise and anti-clockwise of communication is there. So one way it is clockwise, another way it is anti-clockwise. It's a clockwise and will not require that much design. But there is small problem again. You have another device, for example, new device is introduced, new device is added. So again, you have to change the connectivity. You have to change the connectivity. Next, you have to go to each and every PC and say how to communicate each other, how to transfer the data. So that is ring topology. Okay. And here it is. Each device is connected to all other devices. So here it is. Each device is connected to all other devices. So which topology it is?
Star topology.
Mesh
This is
topology.
my favorite.
Mesh topology.
This is my favorite topology because when I put this diagram, I ask the people like, what is this topology? Because still anybody is believing me like me, it is people are still believing that star topology is still nowadays also. That's why I'm asking people. Yes, it is a mesh topology. Mesh top. Not a star topology, guys. Just for easy to draw, people put a star. And immediately when you see a star symbol, the symbol we see that is a star top. But here it is. A PC is connected to all other PCs. A PC is connected to all other PCs. See, A is connected to B, C, D, E also. D is connected to E, A, D, sorry, C, B also. C is connected to D, B, A, E. So every device is connected to all other devices. It is highly redundant topology. Highly redundant topology means earlier days we have a problems. It means a wire is broken, no problem. We have a communication path. All other devices will communicate. Here it is. A device is down, the communication path is broken. Our wire is broken, the communication path is broken. Here a device is down, or a wire is broken, still there is a communication between devices. So that's why it is a highly redundant, reliable topology. Highly redundant, and reliable topology. But it is a complex and it is costly. It is a complex topology. It is costly topology. Complex as well as a, not a costly, sorry, complex topology, not costly, sorry. So we should not say costly here. Cost means there is a cost is there, but it is a complex topology. Very difficult to scalable. Scalability is difficult. Like I said, in a ring topology, if you want to add a one more device, again you have to configure. Here also same thing. You want to add a one more device, again you have to connect like this, like this, like this. Again you have to create. Okay. So it is a very difficult to scalability. Scalability means adding a one more device is very difficult. Complex wiring. Number of NICs requirement is very high. So that is our mesh topology. And where we using this mesh topology, not for your, it's highly redundant, but problem is it's a complex. Of course, number of wires are a requirement is high. Number of NICs per piece is high. Difficult to scalability. Number of devices increases, more wiring, more connecting. But still, some people use these mesh topologies like a SAN storages. Storage area network is then SAN storages. Servers connections, like you have a servers, you need a redundancy. You have a storage devices, you need a redundancies. You have network connectivity, like a core network connectivity, need a multiple connections. So even one server is down, other server will connect and give you the data transmission. In that cases, we use this kind of mesh topology. Look like some diagram. We are not doing any cartoon networks here. Okay. Guys, understand mesh topology. Next one is star topology. The topology we are using in our regular network is a star topology only. Our regularly we are using in a wide network, so we are using star topology. It's much not just for sample. So to create a star topology, you use a central device. Either it is a hub or a switch. You can use hub or a switch. Happen. No meeting. There is a Friday. Also 1 second, guys. Okay. So I need a star. This is a star topology. It means like star blinks. That's why the like this. That's why it is star topology, which is connected. The star topologies in star topologies, devices are connected to centralized device. It can be a switch or it can be a hub. It's a simple LAN network anyway. It is. It can be a switch. It can be a hub. Am I receiving any messages? 14 now meeting schedule here. This is Outlook. I have received a lot of messages. I'll see that. This, no. So last point, guys. Don't give me a biscuit. Yesterday also we have. Okay. So it is very easy to configure, guys. Star topology, easy to configure. Redundancy kind of stuff is not there. Okay, so no redundancy anyway. No redundancy kind of stuff, but reliability is also very less. But it is very easy to configure. But we need a centralized device in all these one device and a cable. But here it is. We are using a a special additional device we are using that is called a switch or a hub. They're all connected to the switch only or a hub only. All communications through this switch or a hub point. So A to B communication or A to D communication or C to D communication. All are we are communicating through this centralized device only. Okay. Here, if in case a cable is broken, so for example, A to switch connection is broken. So A won't communicate, but remaining communication is still going on. If A is down, so A won't communicate, but everything will communicate. But problem is, if one device or one wire is broken, communication don't stop, they will communicate each other in the network. But if in case switch is down, entire communication is down. But one more thing is there, guys, in the star topology, it is not having more redundancy, but it is having a easy to troubleshooting method. So whenever an issue is occur, a cable is down or a device is down, immediately we can understand where is the problem. Where is the problem? A centralized device or a cable. A cable is from other device to the switch or a hub kind of stuff. We can easily understand. How can we understand? By LED. Okay, so you can see LAN P-link, TP-link. I'm typing also, I don't. The net is also slow, guys. So it's slow. Got a problem. So the ending of part is always a problem. My tasks were in a loading mode. Okay, what's it is, guys? This is a star topology. One star topology we can connect it to another star. It is called a extended star. Or we can connect it this star to a router to modem, like we can connect full config. Means we can go to extended star, like a combining one star to another star. We can connect a multiple device, which we cannot do in the both ring topology and mesh topology. But in a star topology, you can do it. You can able to. So this is star topology, and we can do extension like this. This is called a extended top. Connect a one device to another device straight away, like a PC to PC, PC to switch, or PC to router, router to router is point to point topology, point to point. If you connect a device to a multiple devices, called a point to multi-point, point to multi-point topology. If you combine one topology to another topology, for example, you combine mesh topology and star topology, called a full mesh topology, that is hybrid topologies. It's called a hybrid. What is a hybrid? Combination of one topology to another topology. Star plus mesh or point-to-point star topology, that is also called as hybrid topology. Another topology is a tree topology. Guys, you can better to Google it about a tree topology. So generally tree topology means it is maintaining a hierarchical part. Means there is a one main backbone system is there. It is connected to multiple distributed, multiple like there's lot of distributions. So why it is tree topology not here? Okay, important is there is originally as per the standard textbooks there is no tree top. Maybe it is introduced newly, but we don't know. You want to see the tree topology? Okay, guys, these are the what happened. The ecosystems. Have to take one day leave to go and purchase computer system, not a system problem. It is my operating system problem. Guys, are you able to hear? Can you able to see screen or something blank screen you are getting?
Yes, sir.
Screen able to see or blank screen?
Able to see, sir.
Able to see, sir.
Yeah, then it is. So we'll give 2 minutes time to this one. I can't able to do any control or anything. So, but these are the topologies, guys. What are the topologies? Physical topologies: bus topology, ring topology, mesh topology, star topology, hybrid topology. That's it. You want more like point-to-point topology, point-to-multi-point topology, tree topology kind of stuff. And if you want to add more topologies in internet, there is a lot of topologies are there. You can try it also. It is okay now. Okay now. Okay. So this is about your topology. You want to learn, read about each topology also. Description is already there. You can read. To see a topology like this or it like this, you can easily first of all identify what kind of topology it is. Or if you're any interview you are asking, not only now guys, also when you are inside an organization, suddenly say draw the mesh topology. You have to ready to, you have to know what is the advantage, the disadvantage, configurations and all. Okay. So a lot of people again think when we are in this service desk classes, sir, we have to go to core networking topics, then we are going for Airtel customer care. Are we going to put a connections? No, guys. But these are all a basic level of understanding of workings. So, are you clear about the topologies, guys? Physical topology.
Yes, sir.
So, next two topics, important topics, originally important topics are IP addresses. Another one is OSC layers. Both are big topics. Once we complete like a OSC layer, two parts again, not two parts, three parts. OSC layers, TCP IP layer comparison, and troubleshooting using OSC layer model. Okay, three parts. Next one is IP address. IP address and MAC address difference. IP address, IPv4, IPv6. Again, IPv4, IPv4 classes, subnet mask, and network and host portions, that is IP address part. We have little bit time, so I will try. So only one thing is just relax for 2 minutes. You have an energy